Hello, students, and welcome back. Today we'll be working on the opposite operation of what we have been doing. So we have been working on multiplication, and today we'll be working on a process known as factoring. And so factoring is when we want to is done when we want to write our expression as a product. So to multiply, we remove the parentheses, and when we factor, we restore the parentheses. We want to get the parentheses back in the problem. So as we look at our examples, factoring is like dividing, except that we want to write our final answer as a product, so something that shows the parentheses. So we'll take a look at our first page examples, starting off with example number 1, 2x plus 6. So we have two terms. I'm going to show this as dividing. I've been asked to factor this, so I have to think of a number that would divide into both the 2 and the 6. And that number is going to be a 2. What I divide by, I'm going to write on the outside of the parentheses. And then I'm going to write a parentheses. And 2 divided by 2 will give me a 1. Since there is an x, I'm not going to write 1x. I'm just going to write x. And then plus, and then 6 divided by 2 will give me a 3. And this is what we refer to as writing something in factored form. So notice that it went from not having parentheses to having parentheses. This is what we call factoring. I'll move on to example 2. Sometimes the common factor in our terms is not a number, but rather a variable. That's what happens on this one. So we have x to the second plus 5x. I can divide both of these terms by an x. When I have a common variable, I want to use the lowest exponent of those two variables. So I'm going to divide by an x. What I divide by is written outside the parentheses, and then I'll make my parentheses and do my dividing. Now, when I divide variables, I keep the variable base and I subtract those exponents. So 2 subtract an exponent of 1 would give me a 1 as an exponent. And I usually don't write it if it's just x to the first. I'll just write an x plus. And then I have 5x divided by x. Now, on this, your exponents would subtract and give you a 0. So we can think of those x's as canceling, but we still have the 5. And so we have the factored form x times x plus 5. As I move on to number 3, I want to notice always whether or not my expression is written in descending exponent order. And this one is not. So I need to write my 18x to the third first plus 12x to the second next, so that my exponents go down in order. And then I have to think of what will divide into both of those numbers. So I can start with 12. 18 will not divide by 12. I'm going to keep going down. So 11, 10, 9. Now 18 will divide by 9, but 12 will not. We'll keep going. 8, 7, and I finally get to 6. Both of these numbers will divide by 6. And then I have my x, which is a common factor. I use the lower of the two exponents, so x to the second. My common factor gets written outside the parentheses. Then I start a parentheses and do the dividing. So 18 divided by 6 gives me 3. Remember I said when we have variables, we keep the variable, we subtract the exponents. 3 minus 2 is a 1, and I won't write the 1 exponent. Now I'm going to divide positive 12 by positive 6. That's a positive 2. my x's will, when I subtract the exponents, I'll get x to the 0 power. And so that means those x's will just cancel, and I'll just have the 2. So 6x to the second times 3x plus 2. And finally, my last example on this front page, I have, I'm noticing that the exponents are not written in descending order. So I'm going to rearrange, putting 16x to the third first, plus 12x to the second next, and plus 4x third. Now I'm going to look to see what, if anything, I can divide each term by. And I notice that I have a 4, and 16 and 12 and 4 will all divide by 4. And then I'm also noticing that they each divide by x. They each have an x in common. My lowest exponent is just x to the first. So my 4x common factor is written outside of the parentheses, and then do the dividing. 16 divided by 4 is a 4. I have my x's, subtracting my exponents. 3 minus 1 will give me a 2 as an exponent. Plus, I have 12 divided by 4. That is a 3. My exponent, x's, 2 minus 1 will give me x to the first. Plus, and then 4 divides by 4. Now, numbers that divide, I must put the number that I get. So 4 divided by 4 is a 1. My x's will cancel, and since I have already written the 1, I have got an expression for that term, and that would be my final answer. So 4x times 4x to the second plus 3x plus 1. Move on to the back side of your papers. We're looking at factoring by grouping. Now, I tried to explain on the typed up portion of your notes that this is a technique that you can use when you have 4 terms. So when there are 4 terms, this is something that you should consider doing. It's called factoring by grouping. And when you finish, your answer will give you 2 binomials. In other words, a parentheses with 2 terms times another parentheses with 2 terms. Now, I have these examples set up for you, and then I'm going to do 4 more. So you can read through the typed up examples on your own. I'm going to go ahead and work through this factoring problem. So I'm going to start with number 1. I have 8x to the third plus 64x to the second plus x plus 8. The first thing I should do is see if I can divide each term by a number or a variable, but I cannot. And so the next thing I'm going to do is I'm going to draw a cut line. Now the cut line should go between your second term and the sign of your third term. And then I'm going to notice just my first 2 terms. I can divide by a number. Now I want to try to get the biggest number I can. So I'm going to start with 8. Will 8 and 64 both divide by 8? And they will. So I'm going to divide each of those 2 terms by 8. And then I notice that there's an x in common. I want to use my smaller exponent. So I'm going to divide by 8x to the second. Just like we did in the front side, we're going to write that 8x to the second and then start a parentheses. So now we'll do our dividing. 8 divided by 8 is a 1. Now we generally don't write the 1 if there's going to be a variable. And there will be, because we have x to the third divided by x to the second, which is x to the first. Remember that we are subtracting exponents. So I have 1x, which I could just write as x. And then I have a positive 64 divided by 8, and that is 8, and the x to the seconds cancel. So I have in this parentheses x plus 8. Now I'm going to move to the second half of my factoring, and I always have to divide by something. In this process of grouping, you must do this second division. So if there is no common factor, then we divide by a 1. Now, what you divide by will go in front of a parentheses that will be written. But this 1 is positive, and I want to designate that with a plus sign. So positive 1, and then I'm going to start a parentheses. And what I want you to notice is x divided by 1 is x, plus 8 divided by 1 is 8. My two parentheses match. If this process is being done correctly, that will always happen. So if you know that you have the first two terms factored correctly, then you could just go ahead and write down the parentheses for the second part because it must be a match. All right, now this one is not quite finished. It takes one more step. The factor that is the matching parentheses is now your common factor that needs to be divided out. And so I'm going to write it first. And then because I'm dividing it out, I'm actually going to, in this line, mark it out. I think that will help you see that the other factor, the other binomial that we are going to need to write is the part that is outside the parentheses, not marked out. And that would be the 8x to the second and then plus 1. And so there you have your two parentheses that if you multiplied them using your FOIL process, you would get what we started with. So remember, we're trying to find the factors that would multiply to give us our original question. All right, we'll move on to example 2. I see that we have 4 terms. I'm going to draw a cut line. I can look to see if I can divide all those terms by the same number. For example, do they each divide by 2? Well, no, the 21 does not. Do they each divide by 3? No, the 16 does not. So there is no common numerical or variable factor. So having drawn the cut line, now I'm just going to concentrate on our first 2 terms. Is there a number that will divide into both 6 and 16? So I start with 6. Will 16 divide by 6? No. And we can move on down to 5 and then 4. Now 4 will work for 16, but not for 6. We'll move on down to 3. 3 will work for 6, but not 16. And so we land on 2. 2 will divide into both of those terms. So we will divide both by 2. And then we'll check on our variable as well. And both of these terms have v's. So the lower of the 2 exponents is v to the second power. Remember that what we divide by, we write outside of a parentheses that we'll be starting. And now we actually do the dividing. So 6 divided by 2 is 3. And our v's, we subtract exponents, and we'll have v to the first. Then we have minus 16 divided by 2 is an 8. And then our v to the seconds cancel. And so this is the end of that common factor. All right, so we move on to the second half of the parentheses. And we have 21v and negative 56. Now, remember that I told you that the 3v minus 8 is going to have to repeat. So you could go ahead and write the 3v minus 8 and then try to figure out what number will fill in this space that I'm drawing right here that divides into both 21 and negative 56. And sometimes this is a little harder for students. So something you can do on your calculator is check the last number divided by the last number in the parentheses. And negative 56 divided by negative 8 is actually a 7. And that 7 is my common factor. Now, when I write the 7, I want to write it with a plus sign because it is positive 7 that I am factoring out. So my common factor is now my parentheses 3v minus 8. And as I did in the last one, I'm going to mark it out so that hopefully you can see your other factor is what is not marked out. So on the far left, you have 2v to the second, and in the middle, plus 7. And that would be the factored form of your original problem. So we'll be moving on. These last two have a little bit more subtraction. So this is going to change how we deal with the division. I'm going to look at example number 3. We have 28y to the third plus 16y to the second minus 21y minus 12. Again, I might think of 2 or 3 as possible numbers to divide in each one of these terms, but nothing works. So I've drawn my cut line. I'm going to think about only those first two terms. I'm going to have to work my way down from 16 if I can't think of it. So will 28 divide by 16? No. So I can go to 15, 14. 14 will work for 28, but not for 16. So I'm going to keep going. 13, 12, 11, 10, 9, 8. Now, 16 will divide by 8, but 28 will not. So I'll move on to 7. 28 will divide by 7, but 16 will not. So I keep going. 6, 5, and 4. And finally, 4 is a number that will divide into 28 and 16. Likewise, my variables, I want to use my y to the second power. So I write that outside of a parentheses that I will start. I do my dividing. 28 divided by 4 gives me a 7. And then y to the third divided by y to the second, subtracting those exponents, I get y to the first. Then I have plus, and 16 divides by 4, I get 4. My y squareds will cancel. Now, I know that I need a 7y plus 4, but I need to know what number I divide by. So I can take a look once again at my last term, negative 12, and my 4. Negative 12 divides by 4 and gives me negative 3. If my third term is a negative, then I need to divide by a negative. And so my negative 3 is my divisor. You do need to put that negative sign outside of the parentheses along with your number. So our common factor is the 7y plus 4. And notice that it is the same in those two spots. So I'll cancel it. And then my other factor is what's not marked out, the 4y to the second minus the 3. And then my last problem, example number 4, might be just a little bit harder to discover because there are there's more than just one variable. However, I do not have a common variable in each term, nor can I divide out the same number from each one of those terms. So I'll draw my cut line. I'll concentrate just on the front. Starting with 4, will both terms divide by 4? And yes, they will. Always at the beginning, we divide by a positive, so don't divide by negatives on your first term. We can also look to see that we have a b in each one of those terms, and so 4b is what we'll write outside the parentheses. Then we'll do the dividing. 12 divided by 4 is a 3. The b's cancel. I still have a c with that first term. Now I have a negative. 4 divided by 4 is a 1, and I would need to write that 1, except for the fact that I do still have a variable. I have the d. So it is not absolutely necessary that you write the 1 as long as you have your variable. So 3c minus d. All right, now we'll work on the other side of the cut line. What can negative 15xc and positive 5xd divide by? So again, I'm going to try to think of this third term. If the third term is negative, I have to divide by a negative. Both of these divide by 5, and they both have x's. So my common factor is negative 5x. I already know what my parentheses should be, but we can make sure. So negative 15 divided by negative 5 is a positive 3. The x's cancel, and I still have a c. Then I have 5 divided by negative 5. That's going to be a negative 1. And the x's cancel, and I have d. So again, I don't really need to write the 1. I can just write d. So notice that I did end up with 3c minus d as my common factor, and then my remaining factor will be made up of 4b minus 5x. So if you'll notice, the same pattern happened on all 4 of your examples, and all 4 of your examples ended up with 2 parentheses multiplied together as your final answer. This process is known as factoring by grouping, and the last part of your assignment will be that type of factoring. The first part of your assignment will be just factoring using the distributive property. So if you have any questions, please ask your teacher, and good luck on this assignment.